You'd think there'd be so little to say about declaring and initializing variables. But after looking at a bunch of languages and style guides, I have quite a lot to say. Let's start with declaring variables. This is when we tell the compiler the name and type of a variable. Did you know that some languages don't require you to declare them at all? In these languages, you just start using the variable, and the compiler will infer a declaration for it. This is called implicit declaration, and what the compiler infers depends on the language. If our language is typed, meaning that a variable can hold only one type of information, then the compiler has to infer a type. In some languages, the variable will be given a type based on the name that you give it. For example, Fortran will decide that any token that starts with the letters I through N is a variable name, and that variable holds an integer. Any other starting character makes it hold a real number. Other typed languages, the type given to the variable will be the type of the first value you store into it. There is a terrible risk to implicit declarations. Any typo creates a new variable. Forget a capital letter? New variable. Make a spelling typo? New variable. Forget a space? New variable. Clearly, this is not a good idea. Fortunately, most languages have the ability to tell the compiler not to do this. If you can turn it off, you should. If you can't turn it off, consistent naming is your only hope. You and your team need to follow really specific naming conventions to reduce the risk of naming the same thing two different ways. As a last resort, often a compiler can output a list of the variables, and you can use that to flag things that don't follow your conventions in the hopes of finding accidental variable creations. Talking about inferring things about variables, in Java 10, they allowed the use of var instead of the type in a declaration for local variables, not for instance variables. But if you do this, you have to include an initializer that gives the variable its first value. The compiler infers the type of the variable from that initializer. The value of this technique depends on how it affects the readability of the code. Code gets read much more often than it gets written, and it needs to be readable by engineers who did not write it. So the thing we have to worry about is, can the reader infer the type easily and correctly? Well, the most obvious thing that gives a clue to the variable's type is the variable's name. For example, if this is my declaration, I'm not sure what exactly is in result. However, if I rename it customer name, it's pretty easy to infer that it's a string. Naming variables is so important that I made a whole video about it. Check it out through the link above. We can also help the reader infer the type if we keep the scope of the variable as small as possible. That means that the reader doesn't have to look far to see all of the uses of the variable, so finding clues to its type isn't hard. The most obvious way for a user to infer the type is if the type is in the initializer. You have to be very careful when you use var for variables that are being initialized with primitive types. For example, the compiler won't infer byte or short. All integers will be inferred to be ints. Generally, the primitive types are really small to type, so I just don't use var in place of them. I also have one warning about using var in place of a generic type. Consider this declaration. We want mystrings to contain a list of string objects. If I use the full type and leave the generic unspecified in the initializer, everything is okay. The compiler will infer the type of the generic from the type of the variable. If I use var and I leave the generic specified in the initializer, everything is still okay. The compiler will infer the type from the initializer. However, if I use var and I don't specify the type in the initializer, everything is not okay. The compiler won't complain, but the type it will infer is array list of objects, not array list of strings. With no warning, the declaration isn't behaving the way we wanted it to. There are a lot of subtleties to using var well, The best source I've found for enumerating those details is this. In most languages, you have an option to mark a variable as final or constant in its declaration. It's a safety measure preventing code from accidentally stepping on the value. When you do it to a regular variable, the behavior is pretty obvious. However, when you mark a parameter to a function as a constant, different languages do different things. The idea behind marking a parameter with const or final is to ensure that the routine doesn't change the value being passed in. In other words, the caller can rest assured that their variable value won't be changed. That gives the caller a better understanding of what the routine will do, and it sounds like a good idea. The problem is that different languages treat that designation differently. So let's look a little more closely. If a parameter is being passed by value, marking it constant is totally redundant. The variable passed into the call by value parameter can't be changed in any way. While that's pretty simple, there are always details to pay attention to. For example, in C, if we pass a struct into a function, it's passed by value. A copy of the struct is given to the function. If the function changes anything inside its copy, that change won't affect the caller's struct. It's called by value. No need to use const here. When we use const or final with pass by reference parameters, there's some inconsistency in what is actually held unchangeable. There are two things the const could affect: the reference you're given, or the thing the reference points at. For example, if you pass an object into a method in Java, it gets passed by reference. The parameter points at the same object the caller is using. If you mark the parameter as const, the compiler makes sure that you can't give the variable a different object. So the reference is constant. However, even though it's marked final, we can change the fields inside that object. So in Java, final on a parameter means we can't give it a new object, but we can change what's inside the object that we're given. However, Java's behavior is not what all object-oriented languages do. In C++, if you mark an object parameter as const, we can't replace the object and we can't change anything inside the object. So the behavior is very language dependent. In C, you can put the const in two different places to be specific about exactly what you want held constant. Consider this function. We are passing a pointer to an integer. The first const says that the integer can't be changed, and the second says that the pointer can't be changed. The compiler is going to be unhappy with both of these assignment statements. The lesson here is that const and final are good safety measures, but you have to be very careful to understand the subtleties of how your particular languages handle that designation. Having looked at the declaration of variables, let's move on to the initialization of variables. That seems like a pretty trivial topic until you start to worry about what could go wrong with initialization. The real worry is that initialization doesn't happen completely. You could forget to initialize it at all. In some languages, that means it gets a 0 or a null reference, but in others, that means you get whatever value is laying around in memory. That can make bugs really hard to debug because it can make your code behave differently every time it runs. If you're creating a complex type, like an object or a struct, the other thing to worry about is if that complex variable only gets partially initialized. Two things can cause that. You can forget to do part of the initialization, or something can go wrong during initialization. For example, in C++, if a constructor throws an exception, that can leave a partially initialized object, which may never get cleaned up. Well, given that bad things can happen, what are some good initialization practices? Well, the first is, let's have a rule about where initialization is supposed to happen. In object-oriented languages, we should make sure that all class members get initialized in the constructor. That's pretty obvious. But for local variables, things aren't quite as simple. Some people say you should always initialize a declaration. That way we're certain that it gets a value. Other people say that we should initialize variables close to where they're used. This minimizes the distance where people could mess up the value, and makes it clear which part of the code uses the variable. These two things can be the same place if your language allows declarations anywhere in your code. Declaring and initializing close to where it used makes the scope small, which is good. Initializing them right where they're used also helps to make sure that things get reinitialized when they need to. Consider this loop that sums up 5 random numbers. If we wanted to do that 30 times so that we could calculate an average sum, we'd wrap that in another loop. Since we put the initialization right before the loop that used to sum, it correctly gets reinitialized before each pass of the outer loop. If we had initialized it far away, we'd have to be a lot more careful. There are some ways that the compiler can help you prevent initialization errors. First, turn on warnings about uninitialized variables and then pay attention to them. Second, some compilers have an option for automatic initialization of variables. That ensures that they have reasonable default values. But it could decrease the portability if you change compilers. If your code is depending on particular default values, and a change in the compiler changes those default, the change in the compiler will break your code. There's one more initialization topic I'd like to talk about: initialization of memory. When we allocate memory ourselves, like when you use malloc in C, if we don't make an effort to initialize that memory, we might start with whatever data was laying around. There are a couple of ways that we could choose to initialize that memory, depending on what we're worried about. The most obvious value to initialize memory to is all zeros. That makes it clean when we allocate it. However, because that's a value that happens a lot, it doesn't let you see where memory has been used very well. If you're worried about where memory has been used, you might want to initialize memory to a pattern so that you can see where that pattern has been disrupted by memory use. The hex value dead beef is easy to spot and memorable. Or, if you're worried about code accidentally jumping to the wrong part of memory and trying to execute data, perhaps because something corrupts your return control word in the stack, you could initialize memory to an instruction that will cause your program to immediately crash. On Intel machines, you could initialize memory to the hex value CC, which is the debug interrupt instruction. That way, if you start trying to execute uninitialized memory, your code will stop as if you hit a breakpoint. Sometimes your code is sensitive to whatever you initialize the memory to. For example, if we initialize memory to dead beef, and then your code expects to see the lowest bit turned on, it will see it even if you didn't put it there. Changing the initialization pattern during your testing procedures can help you find times where the pattern is accidentally affecting your code. Clearly, there are lots of details to declaring and initializing variables. I've tried to give you the big picture of things to think about, but you need to look at the particular language you're coding in to see exactly what matters.